So since we've covered a few more concepts in programming, we can create some new ciphers. The next most logical one to do, I think, is the Cipher cipher. Now it's not great, but it is slightly less bad than the @bash cipher. This is also a very historical cipher. So Cipher cipher is named after Caesar. So like, this guy who's pretty important, and I'm sure you've heard of him. Anyway, he was a military leader, he was a ruler, etc., etc. Rome expanded the kingdom a great amount, so on. Now, the Cipher cipher itself was used during his military campaigns. He used it to write and send messages in a way that other people couldn't understand. Now, overall, that was successful, but whether or not it was actually due to his cipher is a little bit harder to determine. This was, of course, a long time ago, so there's, of course, some limitation in historical record. So first off, we believe that majority of the people at the time were illiterate, so they couldn't read anyway. Second, even if they weren't illiterate, did they speak the same language? So if they didn't speak the same language, it didn't matter whether or not they could read either. And in addition, even if they saw the document and they couldn't read it right away, they'd probably just assume it was written in a different language and not realize it was a cipher. Which, I guess you could say is successful then, but it doesn't necessarily mean the cipher itself is well crafted or designed. This is a translated quote from an ancient document that talks a little bit about the cipher, and this is how we are aware of it. It explains a little bit of how this cipher works. So on the right side, this diagram uses a shift of -3. So an E becomes a B. We just push everything back. We don't rearrange the alphabet, we just shift it over. Now Caesar, as far as we're aware, commonly use a shift of 3. So the letter A would become a D. So +1 would be B, +2 would be C, +3 would be D. And so if Caesar were to write an E in something using his cipher, that would have more likely been an H. So I have a series here of different encrypted messages that you can try out. We'll start with just a shift of 3 since that was the one that we believe Caesar used the most. So if that's a Z in the encrypted text, then the clear text would be 3 behind that. So -1 would be a Y, -2 would be an X, -3 would be a W. And that's essentially how you decode these. You just go through the line and you just subtract what you need to from each letter. Your flowchart for that is going to look something like this. Well, this is sort of the opposite direction. This is if you want to encrypt it. So if we wanted to encrypt it, which we'll write a program to do that in a few minutes, we would take our clear text first. We would decide on what the shift value is, so 3 or 4 or 2 or -3 or whatever, and then we would start going into this loop. Are we at the last letter of the string? And of course, if we're just starting, we wouldn't be, but we would still check. And if not, then we take that character and we add the shift to it, and then we add that newly shifted character to the cipher, and then we go to the next character. And we just do this over and over again until we get to the end of the line. So of course, if you're decrypting, then you basically do the same thing. You're just flipping the shift value. You would start with the encrypted text and just go through that string, subtracting what you need to from each letter in order, and building up that clear text variable until you are at the end of the string, and then you should have the message. So you can try that out with these. So that first one with the shift of 3, if we subtract 3 from each letter in that encrypted string, the clear text should be war has come. And taking that same concept, you should be able to do the rest. Now these bottom two, I haven't provided you with the shift value. There's only 25 different possible combinations because if you shift by 26, you're back at the same letter you started. So it is better than @bash because @bash has only one possible key, but it's not that great still because you just have to run through all 25. And even then, that isn't necessarily that hard because on some of these, you might be able to figure out what it might be. On that second to last string there, we have that in all by itself. So what words in English are a letter all by themselves? There's not very many. So then we can probably figure that's either A or I, and you've already narrowed down the shift to 2 possible combinations. That last one might be a little bit harder because there are no single letters, but even still, you're only trying 25 possible different combinations. Now, what you can also do is you could write a decryption program in Python and have it solve it for you instead of doing it manually. So I will show you how to do an encryption program, and if you reverse it, or if you just pass through the encrypted text and try different shift values, you should eventually find the clear text. Now, I will share with you what these are in just a moment, so if you want to figure them all out on your own, you might want to pause it and work through them, make sure that you understand the concept, and then continue when you're done. So there's more than one way to do this. As always, there's always more than one way to do something. I'm going to start with the program we've written before. So when we wrote our @bash program, and I have it in here it is. This was the @bash program I wrote, and it was just using the string.replace method. So we have all of these .replace methods in here, and it just goes through the whole alphabet. I'm going to go ahead and grab all of this, and I'll put it in a new document, and then I'll just delete out all of the white space since it's no longer inside of a conditional. And I'll briefly explain what this does in case you have forgotten from the previous videos or in case you didn't see them. So at the start, we are asking the user for the clear text. So that's whatever their message is. That's what they want to encrypt, right? So it's converted to lowercase, and then it is stored back in that same variable. So it just replaces itself. We print an empty string just to create a little space. And then we have the user press enter to continue. Now this is an input command, but it doesn't store the data. So it doesn't matter what they type, and they're probably just going to press enter because that's what we told them to do. It just creates a nice little delay in there before it starts printing out the actual cipher. In here we have a series of string replace methods, and it just goes through the whole alphabet from A to Z, switching it with a capital version of the letter on the other end. The reason why we did .lower was so that way if they wrote with capitals, it would still convert them, because these are looking for this specific character. As far as the computer is concerned, there is a difference between a lowercase a and a capital A. They're not the same letter. The reason we replace it with capitals is because if we replace this lowercase a with a lowercase z, then when we get down to the bottom, it's going to replace that lowercase z with an a again. So we're going to have some problems. And we saw these in the video where we created this program originally. And once it's gone through all of these, it will just print out whatever ciphertext it has stored. So we can modify this to work as a Caesar cipher. A couple things we have to do though. First, we're not flipping the alphabet, we're just shifting it. So this needs to be changed. So I'm going to start this as just a shift of 1, and it will make sense why when we get to that. You don't necessarily have to, but it'll make sense when I get there. And there we go. So B through Z and going back to A at the end. So this would be a Caesar shift of 1. Now if I want to do a shift of 2 or a shift of 3, I would have to rewrite this whole thing, right? If I left it like this, yes, but there are things that I can do to not have to do that. Now, the way that we're programming this is not the way that I showed in the flowchart. I'll show you how to program it in a way that looks more like that in the next video. But we can use a similar structure. We talked about using a loop, right? So going letter by letter. We're not going letter by letter in the message here. We're going letter by letter in the alphabet. So this is different. But we can still use a loop. If A is going to become B, but I actually want it to be a shift of 2, if I ran this again, then A would become B, and the next run through, B could become C. So that'd be a shift of 2, right? So to do that, I need to make a loop. So I can say while, and I need some sort of variable, right? I need a counter. So I'm actually going to call it counter is less than a shift value, then it's going to do all of this. And at the end, it will print, right? Now we need to actually create this counter variable, because if we don't create it, it doesn't know what it is. So let's just make a counter, and let's start it off just as 0, right? Because it hasn't counted anything yet. And we need a shift value as well. I could define that myself, or I could let the user define it. I'm going to let the user define it. So shift is equal to whatever the user decides. It might be a good idea to actually tell them, 1 to 25, so they realize you're asking for a number. And is there anything else that we really need? Okay. So there are going to be some issues here, but let's go ahead and just run it, and then I'll talk about the issues. So I'll save it on my desktop. I'm just going to save it as Caesar.py. And now I can launch the terminal, and we can try it. All right, so cd desktop. So we're changing directory to my desktop, and Python 3, and Caesar.py. All right, type my message. So we could do hello world. And sure, we can use some punctuation in there. Shift value of 1 to 25. So let's say we do 3. Press enter to continue. And all right, so that's obviously not what we want. Oh, there's a couple issues here. I forgot a thing. So we have this shift value, and that's great, and it does equal more than the counter, so it is running this. The problem is I never actually added to my counter. So we need to add in a line that increments the value of the counter. So counter plus equals 1. This is the same thing as saying counter is equal to counter plus 1. It's just a little bit shorter, and programmers like things that make things a little bit shorter. Even if it's just, a minor thing, any little bit of time savingness is welcome. So counter plus equals 1. So let's try this again. So cd desktop, run it, type in your message. So we'll do hello world again. We'll do a value of 3, press enter to continue, and we have a problem. When I typed in 3 here, it didn't actually think of this as the number 3. It thought of this as the character 3. So this is a character that looks like a 3, not an actual 3. If we want it to be an actual 3, we need to convert it. So to convert that character of 3 into the number of 3, all we have to do is we can just type int, and then open parentheses, and then close parentheses, and then whatever is inside of here, it will try to convert. What I want it to convert is what the user inputs. So this goes inside of there, and it will try to convert it. Now, if the user does something problematic, like entering in a letter, that's not going to work, but that's outside of my control at this point. There are things you can program in to not allow them to do that, sort of, or at least give them an error message instead of breaking the program, but we'll get to that later. So hello world, shift value is 3, press enter to continue. All right, so now it's saying that it doesn't support less than between instances of string and int. So why is it saying that? The reason it's saying that is because I accidentally put quotes around my 0, which made that the character of a 0 and not an actual 0, similar to what we just saw here. So we'll save it again, and we'll try running it again. cd desktop, Caesar, hello world, exclamation point, 3, press enter to continue. There we go. All of that to get a small encrypted message. And if we look at what it created, IFMMP, XPSME, and we think about a shift of 3 on hello world, you should quickly figure out that that is not correct. So H shifted by 3 would not be I, that's a shift of 1. So why did it do that? Well, we've got a couple things going on here. First off, when it converted that H into an I, this I is now a capital I, and there are no capitals on this side. So what that means is we need to actually add another line in the end of this loop. We need to make the ciphertext variable become a lowercase version of itself. So we're using that same .lower method that we used earlier. So now if we run this, we will still have a problem, but I'll explain that next. So if I go to the desktop, run it again, value of 3, same issue. It's lowercase now. It did make it lowercase, but why is it the same issue? So a good way to test things out is to actually like print out your variables inside of loops to see what it's doing. So is it actually running this 3 times, or is it not? Is it only running it once? Let's watch and see what happens. All right, so it ran it 3 times, and then it printed that ciphertext again at the bottom. So it didn't do it 4, it did it 3, and then it ran that again. So why is it doing the same thing each time? Why is it not adding to it? The issue actually is up top here. This very first replace method is not replacing letters in the ciphertext. It's pulling back from the original clear text that we started at the beginning. So each one of these is pulling from this hello world way up here. It's not pulling from itself. So that means that we need to make the ciphertext variable equal to this before we even start the loop. So let's create the variable for ciphertext up here actually, and we can call that clear text, and then this becomes ciphertext, and everything should work fine. For real this time. There we go. So that was the shift of 1, this is the shift of 2, that is the shift of 3. That's what we want. So it worked. Now we can go in here and we can clean out this print command from the loop, so that way the user would only end up seeing this last little bit. Now once again, is this the best way to do this? No, absolutely not. And we'll talk about that in the next video, along with showing some other methods. But it is an easy way to do it with the things that we've already learned, adding in the loops. And to go back to my encrypted messages, if you do want the answers to these, you could figure it out by hand. You could make a Caesar Cipher program of your own to decode them, or I could share them with you, and I'll let you decide. So if you don't want to know what they are, then go ahead and stop watching now. But if you do want to know what they are, these are the answers to all of them except for that last one. Thanks for watching. I hope you will join me in the next video where we use a better method to create the Caesar cipher. Even if you're already happy knowing this method, watching the next one anyway is still beneficial because it will go over a few new concepts and talk about why the current method that we just used isn't really that great.